Hi everyone, and once again, welcome back as we are continuing in Module 1, Topic 3, which is what is highlighted here in green. We already did these. And then we are in Lesson 3, which is shown right here, and we are on page 135. Okay, so our learning goals: estimate the product of decimals, analyze patterns of products of decimals, multiply decimals by whole numbers, use the standard algorithm to multiply two decimals, and solve real-world and mathematical problems involving area and volume. Area and volume are coming back. I know that we tested on it in the last unit, the last topic, but it's coming back here. Key terms: kite and composite solid. Okay, the review. We'll round each decimal to the nearest 10 and to the nearest tenth. Please pause the video. I would like you to try each of these. I'll do one for you, I guess, as an example. So if we round to the nearest 10, this is the nearest, this is the tens place, the 1. So the number after it tells us what to do. So the 9 says, make that go up 1 higher. So the nearest 10 is 20. And then to the nearest tenth, now if we're looking at tenths, the 5 is in the tens place, so the 4 is telling us what to do. The 4 says keep it the same, so it is 19 and 5/10. So go ahead and pause and please answer these. And guys, please really just do it. You're not helping your own brain if you are just copying it down. Like, actually think it through and see if you are on track for it. Actually give it a try, please. Okay, so 11 and 96/100ths to the nearest 10. So this is the tens place, the 1. So this one, actually, I'm going to do that differently. I'm going to underline the place value that we're rounding to. I'm going to point to the number that's telling us what to do. So that 1 tells us to keep that a 1. So it becomes 10 because it's to the nearest tens place. And then if we round to the nearest tenths place, now this one's going to seem a little odd because like here, when we rounded, it went up to 20, and then this one is 19 and 5/10. We're going to have a little something different here. Because this one to the nearest tenth, the nearest tenth is, the 9 is in the tenths place. So the 6 tells us what to do. So that 6 says that we're going to make that 9 1 higher. Well, what happens when you make 9 higher is it becomes a 10. So when that 9 becomes a 10, we have to carry the 1 over to the next column. So 1 plus 1 is 2, and we still have the decimal point, and then we have 1. So rounding to the nearest tenth becomes 12.0. So because we're rounding to the nearest 10, that means we are counting by tens: 10, 20, 30, 40, 50, 60, 70, and so on. So that's why this one went down, but then this one went up, and that's okay. So as you were trying that, you may have been a little bit confused on that one. The nearest 10, the tens place is the 2. The 4 tells us what to do. The 4 says keep that the same. So 1, actually, let's put it over here. So 120, and then we just stop, the nearest 10. We don't put anything after it. It's the nearest tens place. Everything after it would be zeros. Here's the tenths place, the 3. The 5 tells us what to do. So remember, 5 or more, raise the score. 4 or less, let it rest. Okay, so it is a 5, so that means we are going to bump this 3 up 1. So we'll have 124 and 4/10. Number 4, tens place is the 4. The 5 tells us what to do. So we're going to bump that 5. That 5 is going to take that 4 and make it go up 1. So it will be 250 is the nearest tens place. The nearest tenths place, that 3 is in the tenths. And this 3 tells us what to do with that. It falls under the 4 or less, so we're going to let that remain a 3. So to the nearest tenths place is this, 245 and 3/10. Number 5, 10 and 888 thousandths. The nearest tens place is the 1. That's the number in the tens place. The 0 tells you what to do. It's under 4, so we're going to keep it the same. So it'll be 10. This first 8 is in the tenths place. This second 8 tells us what to do. So that 8 is going to become a 9. So to the nearest tenths place is 10 and 9/10. Lastly, number 6. The tens place is right here at the 5. The 8 tells us what to do. 8 tells that 5 to go up 1, so we will have 1,200. The 5 becomes a 6, and then we have a 0. 1,260. The tenths place is this first 4. The second 4 tells you what to do. It says to bump, no, I'm sorry, it says keep the 4 the same. It's 4 or less, so we're not going to bump that up anywhere. We're going to keep it the same. So 1,258 and 4/10 is your answer for that. Okay, and let's turn the page. Okay, doing some remodeling. So this is the getting started. We'll see if we can go through this quickly. You previously used an area model to show the product of 2 fractions. An area model can also represent the product of 2 decimals. Write the multiplication problem represented by the area model. And I know a lot of you have already worked on this in Mathia. So when we look at this, we are going to look here at how many rows across we have. So there's 1, 2, 3, 4, 5 rows shaded across. Now this is showing us this is a 1 unit. It's a 1 by 1. It just happens to be broken down into tenths this way and tenths this way. So our rows going across, there are 5 of them, so there are 5/10 shaded in that direction. How many are shaded vertically? So we have horizontally for the first number, vertically for the second. 1, 2, 3, 4, 5, 6, 7. So times 7/10. So then let me just kind of erase these lines that I drew in here. So then the area that overlaps is our product. So that'll be this darker blue area. And if we counted that, so we have 1, 2, 3, 4, 5 rows by 1, 2, 3, 4, 5, 6, 7 columns. So 5 times 7, just like we have here, is 35. Now, the whole big thing is ones. Then we broke it down into tenths. And when we break it down into tenths going in both directions, how many little boxes do we now have? Right, we have 100 little boxes, and we have 35 of those hundreds shaded. So we have 35 hundredths. Okay, number 2 says use the hundredths grid model to use the hundredths grid to model the expression 2/10 times 8/10 and determine the product. I want to show you how I did this without having any colored pencils or highlighters or anything. If you have those, you certainly could use it. I'm going to show you how you can do it without it. So our first factor is 2/10. So 2/10. So that's going to be our rows going across. So here's 1 and 2. So this area down here, these 2 rows are the tenths. So I'm going to turn the paper here, and it's going to look a little funny on the screen, but I'm just going to draw some diagonal lines all the way across, staying within those 2 rows. And that's my 2/10. And then it says times 8 tenths. So my 8 tenths is going to be my vertical columns. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to shade these in. This time I'm going to draw my diagonals in the opposite direction. So I'm going to go this way. Okay. Now you can see that we have an area where we have lines going in both directions, and we've actually created a series of X's kind of going right across here. So that is where our overlap is. Like here it's the dark blue, here it's where we have the diagonals going in both directions, looking like the letter X in each of those boxes. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 2. So 8 times 2, just like we have. Just double checking it is correct. So there are 16 shaded, and there's 100 altogether, so it's 16 hundredths that are shaded. I do want to point out, and I know I pointed this out in some classes, if we have a tenth, this is just kind of an extra, a tenth times a tenth. What does that equal? Remember, when you multiply fractions, just go straight across. So 1 times 1 is 1, 10 times 10 is 100. So it equals 1/100th. So does it make sense then that when we multiply 8 tenths times 8 tenths, our product is in the hundredths place? So this proves it. It sure does make sense. Okay. Benny says that the product of any two decimals that are less than 1 will always be less than 1. Angel says the product can be greater than 1. Who's correct? Please pause, think about it, write an answer. Okay, so if you said Benny is correct, then you are right. Benny is correct. So why is Benny correct? Well, if we have factors that are decimals, then the decimals are less than 1, like here. The squares on the area model that are overlapping are where the product exists. That's where we have that intersection of these two numbers to show us what we get when we're multiplying them. That's always going to be less than 1 unit square, isn't it? We can never fill in some rows, fill in some columns, and end up something that's beyond the 1 entire unit square. So if the factors are decimals less than 1, the squares on the area model that have overlapping shading, or even like in mine, I'm going to kind of put this in parentheses, we could say overlapping lines, will always be contained within the 1 unit square. So the product is always less than 1. Okay, you pause as you finish that. I really wish I had a better document camera. I apologize if you can't see that. Go ahead and pause it. I am going to stop the recording so it's not so long.